Hello, welcome back to Lulumath. This video is on solving systems of equations by substitution. This is part two of two videos. So if you haven't gotten a chance to catch part one, it might be useful to take a look at it before you take a look at part two. So in this example, we're asked to solve the following system of equations by substitution again. And we have two equations right here. So our first equation that we have is 4x minus 3y equals 26. And in our second equation, we have x plus 5y equals negative 5. Now notice in our system of equations, we have two variables, which means we have to solve for x and for y. Now, if you remember in the other video on substitution, all of the problems that were given to you, you had a variable isolated. You had a variable that was alone. But if you look right here, our purple equation does not have a variable that is alone, and our blue equation does not have a variable that's alone either. So the first thing we need to do is get a variable alone or isolate a variable. So I just want to say that we can isolate any variable that we want in any equation. However, I'm going to choose the variable that's going to give me the least opportunity to make a silly or a careless error. So I'm going to try to avoid isolating any variable that might give me fractions or decimals. It's not always avoidable, but if I can avoid it, I will. Also, you're going to have other options when you learn other methods, such as elimination, to not even have to deal with fractions or decimals. So make sure you watch the video on that as well if you would like to see other methods of solving. So if you take a look again at our purple equation that we have here, I can isolate the x or I can isolate the y. It's totally up to me whichever one I want to isolate. If I were to isolate the x though, it has a coefficient of 4, which means that I'm going to eventually have to divide by 4. But if I have to divide by 4 eventually, that means that this negative 3 has to get divided by 4 and this 26 has to get divided by 4, which is not going to allow me to just deal with numbers that aren't fractions or decimals. So I'm not going to isolate the x here. Same thing with the y. Because it has a coefficient of negative 3, I'm going to have to divide the 4 by negative 3 and the 26 by negative 3. Neither one of those is going to be a possibility that will, or an option that I will want to actually explore. So let's take a look at our second equation. X plus 5y equals negative 5. If you notice this x, it's a single x. The x is by itself, not by itself, but it is a single x, so I won't have to divide by anything to isolate the x. So that's what I'm going to try to isolate. So I'm going to take my second equation, x plus 5y equals negative 5, and to get that x alone, I'm just going to subtract this 5y because I want this 5y to go away, and the opposite of addition is subtraction. So negative 5 minus 5y, these are not like terms, so I'm just going to write it down exactly how I see it, negative 5 minus 5y, and that's what x is equal to. Okay, now that I've done that, I can substitute, hence the method of substitution. The name of the method is substitution. The new equivalent expression into the other equation in the system. So we know that our new equivalent expression for x, we know that x is equal to negative 5 minus 5y. So this is our expression right here that's going to replace the x. By writing x equals here, it's now an equation, but I'm only replacing this part right here, which is the new equivalent expression, into the other equation. So the other equation is this purple one that we have up here, this 4x minus 3y equals 26. So once I do that, what I'm going to do is I'm going to, instead of x here, I'm going to substitute in my new expression, which is negative 5 minus 5y. But this is all of x, so it needs to be in brackets right here. And then I'm just going to copy the rest of my equation down. Now, in my original purple equation, I've got two different variables. Now I have one unique variable. Although I see y there twice, it's the same variable, so now it's an equation that I can easily solve. So I am going to go ahead and just copy down this equation that we have right here. Okay, so I'm going to write 4 times the quantity negative 5 minus 5y minus 3y equals 26. Again, I have a unique variable, so I can solve it. Now, since I have this 4 on the outside right here, it means I need to multiply everything by 4 or distribute it through. 4 times negative 5 is negative 20. 4 times negative 5y is negative 20y. Copy down this minus 3y, and then copy down this 26 right here. Collect your like terms, so negative 20y and negative 3y give you negative 23y. We can just copy down this negative 20 and then copy down this 26 right here. Okay, now just isolate the y. So I'm going to add 20 to both sides because negative 20 plus 20 is 0. So I end up getting negative 23y equals 26 plus 20 is 46. Okay, so divide both sides by negative 23, and I end up getting y equals negative 2. Now, since I know that y is negative 2, I'm only halfway done because remember in our system of equations up here, we have two different variables. We've got x's and we have y's right here. We've got x and we've got y here. We've got x here. We've got y. So the next step is we just need to make sure that we solve for the missing variable. And we can use any equation that we want in order to solve for the missing variable. We can choose our purple one that we have here, or we can choose our blue one. I'm just going to randomly choose the blue one for no particular reason. So I'm going to go ahead and get this x plus 5y equals negative 5 written down. And since I know y is negative 2 right here, I can replace this y with a negative 2. Okay, and then I can just copy the rest of my equation down. So x plus 5, this says 5 times y, so 5 times negative 2, okay, equals negative 5, okay. So 5 times negative 2 is negative 10, so I get x minus 10 equals negative 5. Add the 10 to both sides, and negative 10 plus 10 cancels, I get 0. Negative 5 plus 10 is 5. So that tells me that my solution to my system of equations will happen when x is 5 and when y is negative 2. Now I'm going to use Desmos to verify that my answer is correct. So our first equation in our system was 4x minus 3y equals 26. And if you notice on this red line right here, we have infinite points that make up my line. Okay, so if you look, I can drag a point along the line and we've got infinite points that make up my line. And then I'm going to put my second equation in, so x plus 5y equals negative 5, okay? Again, my blue line also has infinite points on the line. However, I have one point that satisfies both equations at the exact same time, and that point is 5, negative 2. So in our next example, we're asked to solve the following system of equations by substitution again. So again, our first thing that we want to do is to isolate a variable. That's our first step. So in our first equation, 3y plus 5x equals negative 41. I don't have a single x or y like we did in our previous example. Same thing with our second equation. I don't have a single x or y like we did in our previous example. So what I'm going to do instead is I'm going to look for maybe possibly a coefficient that might be a factor for the other coefficients or constants in my equation. So for example, right here, in my purple equation, I have 3y and I've got 5x. So the coefficient of 3, I want to see is 5 divisible by 3, not evenly. Is negative 41 divisible by 3, not evenly. Again, if you need to, go ahead and solve it with fractions, but if I can avoid it, I'm going to. In the next example, or the next equation, 12x minus 6y equals negative 6, if you notice this negative 6 coefficient here, I can divide 12 by negative 6, and I can also divide negative 6 by negative 6. So that means that that is probably going to be the easiest variable for me to isolate. So I will go ahead and write down my equation, 12x minus 6y equals negative 6. Okay, and then I'm going to get rid of this positive 12x. Now, a lot of people see this minus sign and think, oh, I got to add the 12x to the 12x, but the minus sign is for the 6y, it's not for the 12x. So I'm going to subtract 12x from both sides. Okay, and don't forget that when you cancel it, it needs to make sure to give us nothing. So 12 minus 12 is nothing, it goes away. So also don't forget that when you bring down this 6y, it's a negative 6y, okay? And then I will copy the rest of this down. So negative 6 minus 12x is what's left over. Now I'm going to divide both sides by negative 6. Okay, and then when I do that, I end up getting y equals negative 6 divided by negative 6 is positive 1. Negative 12x divided by negative 6 is positive 2x. So I have isolated my variable. Okay, so now that y has been isolated, we can substitute the new equivalent expression into the other equation in the system. So here, our new equivalent expression is y equals 1 plus 2x. So now we're going to replace the y for the expression 1 plus 2x. Again, y equals right here makes it an equation, but as an expression right here, we will replace y with 1 plus 2x into the other equation. So the other equation is our purple one that we have here, which is 3y plus 5x equals negative 41, okay? So again, every time I see a y, I'm going to substitute in my expression, which is 1 plus 2x right here. So I'm going to say 3 times the quantity. I'm going to take the y out. I'm going to replace it with 1 plus 2x, okay? Plus 5x equals negative 41. Again, our goal was to go from having two different variables, to having one unique variable. So now that I have one unique variable, I will solve my equation. So I'm just going to rewrite this equation that we have here. So 3 times in brackets 1 plus 2x, or the quantity 1 plus 2x, plus 5x equals negative 41. So I'm going to distribute the 3 through. So 3 times 1 is 3. 3 times 2x right here is 6x. And then I'm going to copy the rest of the equation down. Plus 5x equals negative 41. 6x and 5x end up being are like terms, so I put them together. I get 3 plus 11x equals negative 41. I want to get rid of this positive 3, so I'm going to subtract it to make it into nothing. 3 minus 3 is 0, so I end up getting 11x equals negative 41 minus 3 is negative 44. So now I just divide both sides by 11, and I end up getting x equals negative 4. So now I need to just solve for the missing variable, which happens to be y right now. So I want to solve for y. Again, I can choose any equation I want, totally up to you. So I'm just randomly going to choose the first equation, which is highlighted in purple right here. So 3y plus 5x equals negative 41. I'll go ahead and write that one down, and then I will talk about what to do next. So since I know that x is negative 4 right here, I'm going to substitute that in right here for x. And then I'm just going to copy the rest of the equation down exactly how I see it. So I end up getting 5 times negative 4 is negative 20. So I get 3y minus 20 equals negative 41. I'm going to add the 20 to both sides. The negative 20 and the positive 20 cancel. So I get 3y equals negative 41 plus 20 is equal to negative 21. Divide both sides by 3, and I end up getting y equals negative 7. So that means that my solution to this system is going to be equal to negative 4, because that's what x is right here. So it'll be negative 4 and negative 7. Thank you for watching, and I hope that this video was helpful to you. If you have any questions at all, please let me know in the comments below, or at lulumath.com. You can download the blank or filled in note sheet on lulumath.com. And please don't forget to subscribe and share this video with others. All right, see you next time.